In this video, we are going to be discussing how to solve systems of equations by using substitution. So here are 5 steps to follow for solving systems of equations using substitution. So the first thing that you are going to want to do is to solve one of the 2 equations for a single variable. It doesn't matter which one. Sometimes it will be nice and it will already be solved for you. Some are going to be easier to solve than other ones, so those easier ones are the ones you want to try to pick. So after you've solved for that variable, you're then going to substitute that, what it was equal, into the opposite equation for that variable. You're then going to simplify and solve for whatever variable is remaining. And after you have done that, you found one of the answers. You found what x or what y equals, and then all you need to do is just substitute what you just found into either of the 2 equations and solve for the remainder or the remaining variable. So let's look at some examples. So here we have 2 equations. We have y equals x plus 1, and we have the equation 4x plus y equals 6. So what we want to do is we want to solve for one of the variables. So luckily in this equation we already have one that has been already solved for. It's already y equals something. So this is what we want. This is what we hope to find at the beginning of any problem, or this is what the end result is going to look like at the end. There are 2 other variables that would have been okay to solve for. This x and this y are both totally cool to solve for. The one that's not okay to solve for is this x. Don't solve for that x ever, because you would have to divide things by 4 and then you're going to work with fractions. So that 4x is a no-no to solve, and we'll talk more about that in the next example, picking the proper one to solve with. But again, we already have a y equals, so that's the one I'm going to use. So what this is saying is that y equals this whole x plus 1. So whatever this y equals, so this x plus 1, I'm going to substitute that into the other equation for its y value. So I'm going to take this x plus 1 and I'm going to substitute it in for this y, because we're saying that this y equals this, and it's also going to equal what this y equals, because we're trying to find out when x and y of both equations are going to be the same. So that's why I can use this substitution by saying, hey, this y equals something, so I can substitute it into the other equation because it also equals it. So let's do that substitution. So I have 4x plus, and when I do substitution problems, I'm going to put it in parentheses of whatever I'm substituting, which is x plus 1. So I just rewrote the entire second equation, except where I saw the y, I'm going to substitute what it was equal to in the other equation. So now looking at this problem, I can start to simplify. I don't have anything being multiplied or divided to these parentheses, so I'm going to go ahead and drop them. So I can then add like terms together. I have the 4x and the x. So 4x plus x gives me 5x. And now this is just a 2-step solve. So I'm going to subtract 1 on both sides, leaving me with 5x equals 5. And then I'm going to divide both sides by 5, giving me x equals 1. So I now know part of the solution where x is 1. So I just need to go and try to figure out what my other one is going to equal, what my y value is going to equal. And to do that, I'm going to substitute this x into either of the x's of the equations. It does not matter which equation to use. I'm going to use the top one because it's already solved for y, and that's what I'm trying to solve for to find my answer. So I'm going to take what I just found and I'm going to go and substitute it into this top equation. So let's look at that. So substituting it in, I have y equals the 1 plus 1. So again, I went and I substituted in the 1 that I just found into the equation for x, since that's what x was equal to. So then I can simplify, so y equals 1 plus 1, so y equals 2. So that is the other part of my solution. So now I know that y is 2 for my solution, and we found earlier that x was 1. So my solution is 1, 2. And you can always test that by simply plugging it back into both equations and making sure that that is true. So plugging in the 1 into the top equation, 1 plus 1 is 2, and that's what y equals was 2. Plugging in 1 and 2 into the second equation, 4 times 1 is 4, plus 2 gives me 6, which is also true. So this is my solution. So let's look at another problem. So again, I want to solve this by substitution. So this time around, I don't have an equation where it's already a y or an x equals. So I need to go and create that. So I want to go and look for the best variable to solve for. And the best variable to solve for is the one without any coefficients. So this, and this are all bad ones to solve for. We want to solve for this y because it has no coefficient. So that means I don't have to divide anything for my final answer. So I'm going to go and solve for that y. So I'm going to come over here and we're going to solve. So y plus 6x equals 11. So I'm going to start by subtracting 6x on both sides. So since those are not like terms, I'm just going to keep it as 11 minus 6x. So now that I know what y equals this 11 minus 6x, I can go and substitute it into the other equation. So that's very important that you always substitute what you just found into the other equation. So I'm going to substitute it in for this y over here. So I'm going to take it, I'm going to substitute it in for this y. So let's see what that looks like. I have 3x plus 2, parentheses because I'm substituting something in, and what I'm substituting is the 11 minus 6x, and that equals negative 5. So again, I wrote the entire thing, just where you saw the y, I instead replaced it with parentheses and what y was equal to when I solved for y in the other equation. So now we need to go and start solving for x. So here I have something being multiplied to my parentheses. This is why putting parentheses here is important, because it tells me I need to distribute this 2. So that's where I'm going to start. I have 3x plus 2 times 11, which is 22. 2 times negative 6 gives me negative 12x. It equals negative 5. I then have 2 like terms on the left side that I can add together. So 3x plus negative 12x gives me negative 9x. So now this is just a two-step solve. So subtract 22 on both sides. I get negative 9x equals negative 27. And then lastly, I just need to divide both sides by that negative 9. And I get x equals a positive 3. So now that I know what x equals, so I already know part of my solution is going to be 3 something. So again, I have that 3 by what I just found. So I need to substitute it into any equation and solve for y. So it does not matter which one you go and plug it in for. You could plug it in for this top one up here. You could plug it into the second equation. You can even plug it into the one you just made when you solve for y. And as long as you are comfortable and confident in the math you did, plug it into that one because it's already solved for y. So I'm going to come and I'm going to plug this 3 in for that x. So let's do that. I have y equals 11 minus 6 parentheses, since I'm plugging in something, 3. So let's start simplifying. This is y equals 11. Negative 6 times 3 gives me negative 18. 11 minus 18 gives me negative 7. So my y is negative 7 for my solution. So again, you can go and check to make sure that it's correct by plugging it into the 2 original equations. You can plug in the negative 7 in for y and 3 in for the x of the top equation. So negative 7 plus 6 times 3, which is 18. So negative 7 plus 18 gives you 11. And same for the other one. It will also work out. So you can always check yourself by plugging them back into both of the equations and making sure that they are true statements. So I have 2 for you to try. So take your time and solve. So on the first one, you should have gotten 3, negative 10. And on the second one, you should have gotten negative 1, 6.